All right. Testing latency on the video. It's pretty low now. All right. Day 4. Trying to get out of the pandas hole. So let's get into it.
Parentheses, and then finally you put it inside brackets for your data frame. If you want to do an OR operation, you can just replace this.
All right.
Okay, let's go.
Oh, I did some stuff off screen. Excuse me. Very briefly, it's not a lot. So I'm in a different place from last time, slightly. Oh, hold on. What the heck? Hold on. There we go. Alright, so we're going to catch up real quick. If we want to select a certain row out of your data frame amongst specific columns, do data frame inside your data frame. We're going to select data frame whose columns belonging to W are going to be greater than 0, and instead of using typical Python predefined word, and we're going to use the symbol as used in other programming languages. Set the columns whose values are more than whose values are more than 0 W, and whose values are also more than 1 and Y. That's what we get. Now we kept in Z2, so it's not a problem. Now we would get additional columns if we said less than 0. Just one A&E. Yeah. Yeah. So that's pretty straightforward, I guess.
I'm going to break that down one quick last time. When you're trying to use multiple conditions, you can't use Python's normal and operator. You have to use the ampersand. And then you pass in the multiple conditions in parentheses, and then finally you put it inside of brackets for your data frame. If you want to do an OR operation, you can just replace this with the pipe operator, which is right above your, usually for most keyboards, on your enter key, go ahead and go right above it, and then do shift on that backslash, and this should give you the pipe operator. And that's going to be your replacement for OR, because if you try using OR, you'll get the same error. So that's with OR. If I try it with Python's normal OR, again, I'll get the truth value of a series is ambiguous. And that's because you get a series of those values instead of just one or two Boolean values. Okay, you can go ahead and reference in notes if you want more examples of this, but basically, if you want multiple conditions, pass in each condition in parentheses, and then use an ampersand or pipe operator for the AND or OR. Let's go ahead now and shift gears and talk about index and a little more details about it. What we're going to discuss now is resetting the index or setting it to something else. Let me go ahead and take a look at our original data frame. I'm going to go ahead and clear these cells here by just running them. And let's take a look at our data frame. Again, we have rows A through E and columns W through Z. In order to reset the index back to the default, which is just a range index, 0, 1, 2, 3, 4, all the way up to the nth row, what you can do is call the method reset under...
Okay, I'm going to pause it there. What was it that I used in order to clear out? I don't think I used it. I'm not going to worry about it until I need to.
Underscore index. And remember to close parentheses that we actually run that method. And if you call that, notice you will get the index reset to a column.
Okay.
And you'll get the actual index then to be numerical. And that's how you can reset the index. Something to note here is just like a lot of other Pandas data frame operations, this doesn't occur in place unless you specify it for it to occur in place. So if I call back df, I still have that original index of labels. If you want this to actually occur in place, what you would just do is say in place equals true and pass it into the reset underscore index. For now, we'll go ahead and not do that. That way we still retain our original data frame. Let me go.
In place. So you can shift tab, I think. In place equals false. Okay. Okay. There we go. Alright, well, did that for fun.
Set underscore index. For now, we'll go ahead and not do that. That way we still retain our original data frame. Let me go ahead and clear this out. Again, if you just want to reset the index to a numerical value, you can just use .reset index, and your old index will become a column of your data frame. Okay, let's go ahead and show one more new index example, such as setting the index. And in order to do this, I'm going to go ahead and create a new index called new IND. And I'm going to use a little trick here that I'll explain in just a second. This is going to be a bunch of state abbreviations, and I'm going to say .split on this string. And remember, .split off a string is just a common method for splitting off a blank space, but this is a nice quick way to create a list instead of having to type out every comma. So I'm going to go ahead and set that list equal to new IND, so I have my new index values here. And what I'm going to do is put this as a column in my data frame. So I'm going to go ahead and say df states is equal to new IND, and since the dimensions match, so there's 5 items here, it will match from 0 to 4 here on this data frame. So if I check out my data frame, I have this new column called states, CANYWYORCO. Now we know how to reset the index, which is just doing the .reset_index method. But if you have a column in your data frame that you want to be the index, what you can go ahead and do is say .set index instead of reset index. For example, I could say df.set_index and then pass in the column name you want to be the new index, such as states here. And if I do shift enter, now the states column has become the index. Keep in mind, unless you retain this information of the index, this will overwrite your old index.
Spelling. No way.
Index, and you won't actually be able to retain this information as a new column, unlike reset index that allowed you to have that new column. Okay. So that's set index versus reset index. Again, if I check out my data frame here, this wasn't in place. I would need to add the argument, I do shift enter here, in place equals true. Let me go ahead and just do a quick review of what we just covered before we head up to part 3.
It's over already.
Okay, we learned about conditional selection, which is very similar to NumPy operations. You basically get a data frame of Boolean values, and if you pass in a whole data frame of Boolean values, you'll get the values where it's true, and you'll get NaN or null values where it was false. If you pass in a series of Boolean values, such as a column with a comparison operator, you'll end up only getting the rows of the data frame where series happen to be true. And you can break this down into multiple steps if you want to. Again, these 2 cells are probably the most important to understand out of this lecture. If you understand this, then you understand how to do conditional selection in Pandas. Then, scrolling down, if you wanted to do multiple conditional selection, you can do an ampersand or a pipe operator to do multiple selection in Pandas. Then, if you understand this, then you understand how to do conditional selection in Pandas. Then, scrolling down, if you wanted to do multiple conditional selection, you can do an ampersand or a pipe operator. You cannot use Python's built-in and or operators because of the ambiguous values in a truth series. And remember to use parentheses to separate each conditional selection statement. Then finally, you have reset index. Reset index is just going to reset your index to a numerical index and take your old index and set it as a new column called index. And then you can set a new index instead of resetting a new index based off a current column just by saying set_index. And both these methods are not in place by default, so make sure to specify in place equals true if you want the change to be permanent. Alright, that's it for this lecture. Thanks everyone. I'll see you in the next lecture where we'll discuss index hierarchy. Again, all these notes are just in the notebook called data frames. Thanks, and I'll see you in the next lecture.
Cool.
Hello everyone, and welcome to the Data Frames Part 3 lecture. In this final lecture of the Data Frames series of lectures, we're going to learn about multi-index and index hierarchy. We'll first create a quick example of what a multi-index data frame looks like, and then how you can work with data frames that have a multi-level index. Let's go ahead and jump to Jupyter Notebook to get started. Alright, here I am at the Jupyter Notebook. What I'm going to go ahead and do
Sounds complicated. I'm scared.
is copy and paste
Alright.
some lines of code that are available for you in your notebook called Data Frames.
Okay. Is copy cell different from copy text? I feel like it is. Alright, we're just gonna control C it. Cool.
If you scroll down until you get to the multi-index and index hierarchy section, you'll see these 4 lines of code. These are the 4 lines of code we're going to use to actually build this data frame. You can go ahead and check this out. We'll say outside, and that's just a list. So we have 6 items in this list of 2 different types, G1, 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 and then G2, G2, G2. We have inside, which is 1, 2, 3, 1, 2, 3. And then what we went ahead and did was using the zip function along with the list function. Is we said higher index, we went ahead and used the zip and list on this in order to make this into a list of tuple pairs. So G11, G12, G13, G21, G22, G23. And then I passed it into a special function from pandas. And we actually won't be working with this function at all throughout
Slow it down.
the course, but this is to make this into a list of tuple pairs. So G11, G12, G13, G21, G22, G23. And then I passed it into a special function from pandas. And we actually won't be working with this function at all throughout the course, but this is just for a customization of making a data frame. So don't worry too much about it, but I just want you to be aware of it. It's pd.multi-index from tuples, and it can basically take in a list that looks like this and create a multi-index from it. So after you're done with that, you'll get this multi-index with several levels. G1, G2 has one level, 1, 2, 3 has another level, and then labels. And we'll go ahead and explain what all that means as we create this data frame. But for now, you can just feel free to copy and paste this code directly from the notebook, since it's not important as far as creating the data frame from scratch. We'll go ahead and say pd.dataframe, pass in rand n, 6, 2. So we'll have 6 rows by 2 columns, and then I'm going to set the index to be the higher index object we just made, and then I will set the columns to be a list of A and B. Set the columns to be sin rand n, 6, 2. So we'll have 6 rows by 2 columns, and then I'm going to set the index to be the higher index object we just made, and then I will set the columns to be a list of A and B. Alright, and you can feel free to copy and paste all this code from the notebook, because it's not that important. This is just for actually constructing a multi-index level data frame. And let me show you what I mean by that. Here, if I actually show the data frame, I can see that it has 2 levels of an index. It has this G1 and G... G2 level, and then this sub or inside level 1, 2, 3, 1, 2, 3, and then 2 columns. And this is what a data frame looks like when it has multi-levels of an index, otherwise known as an index hierarchy. Let's go ahead and show how we can actually call data from a multi-level index. For this index hierarchy, what we can go ahead and do is say df.loc, and then we can go ahead and using bracket notation, grab from the very outside index. For instance, if I want everything that's under G1, I can just pass in G1, and I get that little sub data frame in return, which is basically these first 3 rows for those 2 columns. And then I can continue indexing off of this,
Next one.
such as ILOC or .loc, either one's fine, and then passing in a number. And that will actually then return these 2 items here as a series. So the basic idea is you call from the outside index and continue calling inside deeper. If you actually want to name these index,
this is going to be this. Yeah. 03 2655 2665 169 3723.
inside deeper. If you actually want to name these index names, so right now they are unnamed, that's notified by the fact that there's no name in these 2 cells. What you can go ahead and do is say df index.names, do shift enter, and you should get a frozen list that's none. And this is just a pandas index names object types. All it's saying here is that these indices don't have any names. What you can go ahead and do is say equals, and then pass in a list of names. For instance, let's go ahead and call this outside index groups, because it starts with G, and then we'll call the inside index NUM for numbers. And now when I call my data frame, we have groups as a labeled index on the outside, and num as a labeled index on the inside. And this can have as many layers as you want. Hopefully you can begin to see how this would be useful for multi-level index information that you want to use along with a data frame. Let's go ahead and show you how we can grab information off of this one more time. Imagine we wanted to grab this value right here, 0.072, the one I have highlighted.
Let me do it myself. Now this is row 2. Inside of row 2, what are we gonna do? Dot LOCB? Maybe? I feel that's wrong. Oh, we got it. Yeah, we got it.
Well, that's under G2, number 2, column B. Let's start from the outside and work our way in. We'll go ahead and specify that we want .loc G2. Now returns this data frame. Again, we're looking for this value here, so let's go ahead and do one more index. And we can go ahead and call here 2. And then we have under column B, or index B, excuse me, for the series 0.07. So then finally we just call B at the end. And that's how we can grab all the way from the outside to the inside.
Oh, we didn't even have to add locate. We've just done that.
This particular value. What you should do now is pause the video, select another value, and see if you can successfully index it and return it back.
Nah.
Okay.
Already did it.
Hopefully you're able to do
By
that.
myself.
Let's go ahead and show you one last very useful function called cross-section, and it's going to be XS. So this returns a cross-section of rows or columns from a series of data frame, and you're going to use this when you have a multi-level index. So again, our data frame looks like this. Let's say we wanted to grab everything that was under G1. I can do what I just showed you, LOC G1, and that returns the data frame under G1. But another option for a multi-level index is using this XS, this cross-section, and then passing in G1 also as a string. But what's nice though,
So it's gonna okay, I see.
about this cross-section is it has the ability to skip or go inside a multi-level index.
Right.
For example, let's say I have this data frame here, and I want to grab all values of number equal to 1 with both groups in it. Meaning I want, what I highlight here, 1, and then 0.3 and 1.69, but also I want this value, 0.16, 0.18. So I want all values where num, that inside index is equal to 1. This sort of indexing is tricky for something like .loc methods, but it's not so bad with the XS or cross-section method. What you end up doing is specifying what you want as far as num equal to 1, and then you have to indicate as a second argument level, and then pass in the name of the index. In this case, the name of that index is num. So essentially this allows us to grab a cross-section where level equals num is equal to 1. And that's where you're mainly going to be using this cross-section. And now we see both groups where level num happens to be equal.
Fascinating. DF. XS. So we're looking for, I don't know, 3. Or the level is, well, I mean, for being honest, the level is 1 there. Level's num. Level's B. If I was literally looking for 1.6, 1.69, can we do that? 1.69. Excuse me. 1.69 level is equal to B. Nah. Okay, maybe it's because B isn't a level. Alright, so if we did level, let's do level 3. Or level tweaking. Level num. And the value that we're looking for is 3. 4, 3. Boom. Boom. Inside G1 and G2, we get those two level 3.
Equal to 1, and that's sort of data frame gets returned.
Cool.
Okay, don't worry too much. This is pretty advanced usage of pandas. I just want you to be aware of it.
Really?
Later on, as we learn more about data visualization and you start reaching your data capstone projects, we'll revisit this cross-section method to actually grab stock index data. But for now, I want you to be aware of
Really?
it, but don't worry as far as being tested on it, because this is more advanced usage, and you won't see this sort of stuff very often throughout the course. In fact, it really only shows up once in one of the more advanced data capsuling projects. And there's an explanation of how to use cross-section again, so we'll go ahead and give you a refresher before you see this topic again. For now, this is more just an advanced overview of multi-index topics and index hierarchy topics. Mainly what you're going to want to do is index from the outside in, step by step, to get the data you want out. Okay, thanks everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the Missing Data lecture. In this lecture, we're going to show a few convenient methods to deal with missing data in pandas. A lot of times, when you're using pandas to read in data, if you have a missing point, what's going to happen is pandas will automatically fill in that missing point with a null or NaN value. Let's go ahead and explore how we can use methods such as drop NA or fill NA to actually drop those missing values or fill in those missing values. Let's go ahead and jump to Jupyter Notebook to get started. Alright, here I am at the Jupyter Notebook. What I'm going to go ahead and do is create a data frame, and just like we could create a series from a dictionary, we can actually create a data frame from a dictionary as well. This dictionary is going to have 3 keys in it. It's going to have key A, key B, and key C. And what these are going to be are columns in our data frame. And what we can do for the actual data points is pass in a list of values for each key. And those will be the data points for each row in that column name. We'll go ahead and say key A, values. Let's go ahead and jump to Notebook. What I'm going to go ahead and do is create a data frame. And just like we could create a series from a dictionary, we can actually create a data frame from a dictionary as well.
Right.
This dictionary is going to have 3 keys in it. It's going to have key A, key B, and key C. And what these are going to be are columns in our data frame. And then what we can do for the actual data points is pass in a list of values for each key. And those will be the data points for each row in that column name. We'll go ahead and say key A has a list, 1, 2, and then we're going to use np.nan to signify a missing or null value. Then we're going to say for key B, it's going to be 5.
Sorry, missed a step.
That column name.
Okay.
We'll go ahead and say key A has a list, 1, 2, and then we're going to use np.nan to signify a missing or null value. Then we're going to say for key B, it's going to be 5, np.nan, np.nan, and then finally key C, our third column, it's actually going to retain all values, 1, 2, 3, so it has no missing values. And then we can go ahead and say is df is equal to pd.dataframe, and then pass in the dictionary D. And then when we check out our data frame, we get this nice looking data frame of columns A, B, and C, and then rows 0, 1, and 2. Note, row 0 has no missing values. And
Excuse me. Name nan is not defined. np.nan, np.nan, np.nan. Data frame that argument that we are passing in. Cool. Now we have 3 NaN values, undefined values, in our data frame.
column C has no missing values. And then there's a few missing values here in row B, or column B, and 1 missing value in column A. Let's go ahead and explore the drop NA method. A lot of times, you just want to drop missing values from your data set, especially if it's just a few missing values. If you say drop NA just by itself and call it as a method with closed parentheses, what occurs is that pandas is going to drop any row with any single or 1 or more null or missing values. Meaning, if any of these rows had a null value in it, 1 or more, it went ahead and dropped them. If you want to perform this action on the columns, what you can do is check out Shift tab here and notice that there's an axis argument.
It's the first argument. Not first, but you know. Rows we're gonna do for columns. So I'm saying axis equals 1, right?
That means by default the axis is 0, meaning the operation occurs along the rows. But if you want to do the operation along the columns,
yeah. Drop NA, so it's gonna drop all the columns in which there's no values.
meaning drop any columns that have a null value, you can specify axis is equal to 1. And that's going to drop any columns with a null value.
All that's left is C.
Let's go ahead and see the comparison here. And that means df drop NA drops any rows with any null values in it, and then df drop NA with axis is equal to 1 is going to drop any columns with null values in it. What you can also do is specify a threshold. And if we go ahead and check this out, we'll say df.drop NA and use Shift-Tab to check out the documentation. Notice that there's a thresh argument. And what the thresh argument is, it's an integer value. And you will require that many non-NA values in order to not get dropped. For instance, let me go ahead and set the threshold equal to 2. And again, we're just going to do this along the rows. So notice here how we have in row 0, 3 non-NA values. In row 1, we have 2 non-NA values. And in row 2, we have only 1, this number 3 non-NA values. That means if I say drop NA like this, it drops everything but row 0. However, if I set the threshold to be equal to 2 and run this, it went ahead and kept row 1. And basically what that means is because row 1 had at least 2 non-NA values, so 2.0 and then 2, it went ahead and kept that row. Alright, let's go ahead and move on to fill NA. Right now we just focused on just dropping missing values, but a lot of times you'll want to actually replace those missing values. If we take a look at our data frame again, we have these missing values here. If we wanted to fill in those missing values, we can use the fill NA method. And this, if we go ahead and take Shift-Tab here, has a couple different arguments, but notice it has a value argument. And what you can do here is, as a value, set in your fill value. I'm just going to pass in a string to make it very obvious here what's going on. And notice it was able to fill in that value with whatever value we wanted. In this case, just a string that said fill value. However, a lot of times what you're going to want to do is actually fill in the value of maybe the mean of the column. And you can do that, for example, as such. You can say df of A, so that's my A column, and notice I have a missing point here. I'll go ahead and say fill NA, and I will set the value to the mean of that column. And now, that value has been filled as the mean of the value. Now there's a whole philosophy and way of thinking and statistical methods for filling in missing values appropriately.
Right.
I'll let you go ahead and explore those on your own, since they really depend on what...
That seems like the most... let me show you. That just seems like a really inefficient way. It seems like a way that could cause a lot of issues. Because how are you going to predefine it to have a null value? And your entire thing be dependent on you filling in a value manually for the mean. That just seems like a lot of work that's going to get messed up.
We can use the fill NA method. And then...
Alright, let's do it. So we do df.fill NA, right? Do fill NA with a value equal to, let's make it zeros. Let's do it 0.0. Make it fancy. Alright. Actually, no, we didn't do threshold yet. Thresh is equal to 2. Actually, no, it's 1, right? How does this work? Oh, in place, limit, downcast, returns. How does this work? Oh, no, it's drop NA threshold. Yeah. Threshold. Require that many non-NA values. Threshold is 2. Cannot be combined with how. So it's 2, that means only the first 2 rows are going to be kept and not the last row. Oops. Okay. I'm say equal to 1, that just means we're going to get back to what we were at before. I'm sorry. No, that's not what that means. If the threshold is 2, right? If we have 2, if it has 2, we drop it. Or if it only has, if it has 2, we drop it. If it only has 1, I don't understand this now. I was like, threshold is at least 1. So it's drop in A. Threshold is at least 1. Now threshold is at least 2. Or 2 or more. Bro, I'm tweaking. I don't understand how this is picking. That's Chat GPT. How does fresh NA work? I'm tweaking. And pandas, right? So that's what we're doing. That's what we're using right now. Not NumPy, yeah, we're doing pandas. How does fresh work in the drop in a method? Explain like I'm a toddler. Alright, imagine if you have a full table full of boxes like a grid. Each box you can have a toy, a value, an empty, missing, or be empty / missing. Let's say you have to clean this up by getting rid of some of the empty, some of the messy rows or columns that are mostly empty. That's where thresh comes in. What does thresh means? It means keep only the rows or columns that have at least this many toys, not empty boxes. Ah, okay. We have at least 1 toy. If we have at least 2, we keep it. Got it. ChatGPT is goat. If we have at least 1, we keep it. We're here. We're here. We're here. Alright. Tell you, man. Explain like I'm a toddler.
Yes, if we go ahead and take Shift Tab here, it has a couple different art.
Alright, fill in A. Let's go to that one next. Alright. DF, fill in A. Okay, fill it with value. Alright, value. We're going to set that thing equal to 0.0. I think we already did this before. Yeah. Now if we want to do it, a string. We're just going to do it for fun. Fill me up. Yeah. Tough. I'm going to do something a little bit more. Chill. Like unused cell. Cool.
Arguments, but notice it has a value argument.
Right.
And what you can do here is, as a value, set in your fill value. I'm just going to pass it was able to fill in that value. However, a lot of times what you're going to want to do is actually fill in the value of maybe the mean of the column. And you can do that, for example, as such. You can say df of a, so that's my A column, and notice I have a missing point here. I'll go ahead and say fill an A, and I will set the value to the mean of that column. And now, that value has been filled as the...
That's a crazy way to do it, at least in my opinion. I don't know how else you would do it, but that seems like a ridiculous way to do it. Fill in a value to be equal to the df dot mean df a dot mean. Got you. Fascinating.
the mean of the value. Now, there's a whole philosophy and way of thinking and statistical methods for filling in missing values appropriately. I'll let you go ahead and explore those on your own, since they really depend on what kind of data you're working with. For now, all I want you to be aware of is that there's a fill NA method and a drop NA method.
Right.
Okay, that's it for now. Hopefully you remember just that these two methods are available for you, and you can specify what access you want to perform the action on, as well as the thresh argument and the value argument. Alright, thanks everyone, and I'll see you in the next lecture. Hello everyone, and welcome to the group by lecture for pandas. In this lecture, we're going to show you how to use the group by method to allow the group rows data together and call aggregate functions. Now, before we actually jump into the Jupyter Notebook, let me quickly use the group by method to allow you to group rows of data together and call aggregate functions. Now, before we actually jump into the Jupyter Notebook, let me quickly explain what group by is, in case you don't have SQL experience or SQL experience, where most people are familiar with what a group by statement actually does. To put it simply, group by allows you to group together rows based off of a column, and then perform some sort of aggregate function on them. For instance, in this example here, we have 3 partitions of IDs, 1, 2, and 3, and then we have several values for them. We can group by the ID column and aggregate them using some sort of aggregate function. An aggregate function is basically just a fancy term for any function that takes in many values and then spits out or outputs a single value, such as taking the sum of a bunch of values and outputting the result, or taking the average or standard deviation, etc. These are all aggregate functions, and that's all a group by method does. It allows you to choose a column to group by, it gathers all those rows together based off that column value, and then you perform some sort of aggregate function on it. Alright, with that being said, let's go ahead and learn how to use group by with pandas. I'm going to go ahead and jump to the Jupyter Notebook. Alright, so here we are at the Jupyter Notebook. I went ahead and copied and pasted this line of data. It's basically just a dictionary from the notebook, and this notebook is just called group by, and it's under the pandas folder.
Let's get into it. Is this no. Group by, here we go. Oh. Oh shoot. I read that wrong. I read it wrong. I'm sorry. Cool.
Okay, you can go ahead and type this out manually, but I would just say go ahead and copy this data. It's just a dictionary, and then you can go ahead and say pd.dataframe, and then pass in that data dictionary, and it should automatically. automatically then create a data frame that looks like this. And basically this is just some made up data. We have a company column with 3 company codes, Google, Mac.
Create the data frame. Data. Yeah. With. Just gonna do a little df. Data. Sorry. PD? Yeah. There we go. My American boy.
Microsoft and Facebook. Then we have a person column with a bunch of unique people in it. And then we have some sales numbers, 200, 120, etc. Now what we can do is use the group by method to group rows together based off of a column name.
Okay.
For instance, let's go ahead and group by the company.
Google, Microsoft, Facebook.
I'm going to go ahead and say df, and then you say group by, you call it as a method, and you pass in the column you want to group by. In this case, I want to group by the company column.
df. Grupa bio company Ooh. That's not how you do it.
And notice what I get out here. If I just do this, I will get a group by object, and it just points to where it's stored
Already
in memory.
got that.
What I can do is store this as a new variable. So I can say something like by com for
Wait,
by
why
company,
does it do that?
new variable, stored in memory. What I can do is store this as a new variable. So I can say something like by com for by company, and I have this group by object. Then the second step of using group by, after you've grouped by that column, is to go ahead and call some sort of aggregate function on it.
Okay.
So for example, if I wanted to get the mean by company, it would look at the sales column and give me the mean or average sale by the company. The reason it can't do this for the person column is because these are strings, and there's no way you can just take the mean of a string.
Right.
And that means Pandas just automatically ignores anything that's a non-numeric column. Likewise, we can go ahead and perform up.
What's happening? Type error. Yeah, we're gonna run this through ChatGPT, because I don't know. Type error, aggregate function failed. How function mean, data type object. But we grouped it by group by company. Find the mean. What we do, sales. Oh my gosh. So we can't, it's not going to be smart. It's not going to be smart. It's going to return us an error. You can't just tell what I'm trying to do. Oh, the teacher failed me. How old is this? This must be new. This thing's 5 years old. Alright.
Other aggregate functions, such as sum of everything as far as sales per company. You can even do standard deviations with STD, etc. And you should notice that what I get back is an actual data frame with an index called company and the column value of sales. And that means...
Alright. So why is sales not working? Could not convert string to float Sam. Doesn't make any sense. Oh, we're gonna have to. It's okay. It's an issue for later.
I could do stuff such as index off of this. So I could say, by comp, let's go ahead and sum up all the sales by company. So I have that sum of sales by company, and then I could even call something like .loc FB. And that gives me the sales sum of Facebook. Now, a lot of times, what you're going to be doing is not actually setting this group by object as a variable. You'll probably just call this all in one line. Setting this group by object as a variable, you'll probably just call this all in one line once you start getting really comfortable with pandas. You'll say something like group by company, then you'll call something like sum, and then if you just want it for Facebook, you would call FB. And that's all the same thing, just in one line now. Some other useful
So it treats it as if you're concatenating, I think that's the word, the string itself when you run sum. So it literally takes the sum of the person string and the sales, whatever data type you have is that. And it's already grouped by the company. So yeah, it doesn't just focus on sales by itself. Or I said FB, right? Yeah. Yeah, it doesn't just take the numeric. It doesn't just only focus on the numerical values by itself. I guess? I don't exactly know. This is being weird.
aggregate functions.
Or this boot camp's just a little old.
That you may find yourself doing are things such as count, which just counts the number of instances per column. And in this case, it was able to return the person column because it's able to count how many instances of a person occur in that column per company.
Okay. Group by company. We're gonna run this back at the top. Count. If it runs us an error. Oh.
have 2 people and they have 2 sales each, and that makes sense. You can also do things such as max and min. And note here that it also returns the person because Python is able to store things in alphabetical order, and that's basically what it's trying to show here. The max is the latest towards the end of the alphabet, and if you call min, that's the earliest in the alphabet, so you can see we have A's and C's here. However, you probably shouldn't be using min or max with a string column. You'll probably use all these aggregate functions really with numeric columns. One last useful thing I want to show you with group by is a lot of times you can use group by with the describe method, and that gives you a bunch of useful information all at once. So you can say df.groupby, the company name, and then say describe, and it will give you a bunch of information. So for instance, the count, the mean, the standard deviation, the min, and
No kidding.
bunch of information. So for instance, the count, the mean, the standard deviation, the min, and the max, as well as the quartile values for each company. And if you don't like this format, you can actually transpose this.
Okay, wait. Never mind. That's so strange. Yeah, we have. I like the way it's organized better. Count, mean, standard deviation, min, max, percentiles, and sales. Yeah.
So you can say something like transpose if you prefer each company to be a column instead of an actual index. So whatever format you like better, you can describe to that. And then you can actually just call column names off of this if you're just interested in a single company or a single column. Alright, that's really it for group by. It's quite basic. You just call the data frame, say dot group by, the column you want to group by, and then whatever aggregate method you want. Remember, it has to aggregate the column values to a single value. And it usually only works on numeric columns depending on what kind of aggregate function you're working with. We'll get a lot more practice with group by as we go through the exercises as well as the capstone projects. Alright, thanks everyone, and I'll see you in the next lecture. Hello everyone, and welcome to the lecture for merging, joining, and concatenating data frames. In this lecture, we're going to learn how to combine data frames through a variety of methods. Instead of actually live coding everything out, since these methods and commands are actually really simple, and most of the typing is just actually creating the data frames to merge or join together, what we're going to do is just walk through the lecture notebook for this lecture. It's called Merging, Joining, joining and concatenating, and it's under the pandas folder. Let's go through a variety of methods. Instead of actually live coding everything out, since these methods and commands are actually really simple, and most of the typing is just actually creating the data frames to merge or join together, what we're going to do is just walk through the lecture notebook for this lecture. It's called Merging, Joining, and Concatenating, and it's under the pandas folder. Let's go ahead and jump to that Jupyter notebook now. All right, here we are at the Jupyter notebook for merging, joining, and concatenating. First off, we're going to create some example data frames to work with. Here, I've imported pandas as PD, and using a dictionary and a list of index numbers, I've created 3 data frames, df1, df2, and df3. If we take a look at these data frames, we'll see that we have df1, which is columns A, B, C, and D, and indexes 0 through 3. And then df2 has the same columns, except the indexes are 4 through 7, and then df3 has the indices 8 through 11.
Yeah.
Let's talk about concatenation. Concatenation basically glues together the data frames. Keep in mind that the dimensions should match along the axis you're trying to concatenate on. For this, you just use pd.concat and then pass in a list of the data frames to concatenate together. Here.
Dimensions to match the axis you're trying to concatenate on. PD. Cat passing data frames. Axis. Okay.
Here, I'm going to concatenate data frames 1, 2, and 3 by passing them into a list into the pd.concat function. Here we can see that by default, the axis to join on is 0, meaning it's going to join the rows together.
Right.
And we see here that this successfully concatenated, or basically glued together, the data frames. And we can see now we have A, B, and C, and D as columns, with the indices 0 all the way up to 11, with each of the data points lining up nicely. Now you can also specify axis is equal to 1 if you wanted to join and merge along the columns, or concatenate along the columns. And this is an example of what happens when you use pd.concat on these 3 data frames along axis is equal to 1. Notice here we have a bunch of missing values, and that's because these data frames didn't have values for all the indices that you wanted to concatenate on. For example, with data frame 1, A, B, and C, and D, you had index values for 0 through 3. However, for 4 all the way up to 11, you have no values, and that's why it filled it in with nulls when you joined this or concatenated it on data frame 2 and data frame 3. Which basically means when you're working with concatenation and pd.concat, you'll want to make sure that you have information lining up correctly when you join on the axes. In this case, we wanted to join on axis equals 0 to line everything up correctly. Had we specified to join along the columns with axis equal to 1, we'll have a bunch of missing information. Most often, you'll probably be joining columns together, so you'll in fact be joining along axis is equal to 1. However, make sure you know your data and what you actually want to concatenate before choosing an axis. Alright, let's go ahead and move along. We'll create some more example data frames, in this case, one called left and one called right. Here, if we take a look at left, we have columns A and B with some values in them, and then we have a key column, K0 through K3. We have a right data frame, which is a very similar data frame except it has different columns, C and D. However, the key column is exactly the same as the left. So I have a left data frame and a right data frame. Pandas is capable of using the merge function to do merge logic that's very similar to merging SQL tables together. And if you don't work with SQL, you don't have to worry too much about this, but I'll show you the basics of how to merge 2 data frames. You just say pd.merge and then pass in the left data frame and the right data frame, or just pass in data frame 1 or data frame 2, whatever data frames you want to merge together. By default, it will merge them on inner, and if you're unfamiliar with inner as regards to SQL merging, don't worry about it, just use the default inner. More importantly, learn about this on. Basically, when you're merging, you're going to want to merge on a key column, and you can actually pass in 1 or more key columns, which you'll see later. But basically, what's happening here is we're going to combine or merge these data frames together on this key column. And that way, instead of concatenating them, we would have 2 key columns. We can merge so that we merge them or join them on the same key column that they share. So the logic here is when you're using pd.merge, instead of just gluing the data frames together, you're going to see where the values match up on columns, in this case, the key column, and then create the rows using that key column.
Right.
Let me go ahead and show you a couple more complicated examples. Here I have left and right data frames. And we'll notice here that they have 2 keys, key 1 and key 2. Otherwise, they're exactly the same as the left and right we just saw earlier. You can use pd.merge, just pass in the first data frame and the second data frame, and then you can specify on, and you can pass in a list of keys if you want to actually merge on multiple keys, such as key 1 or key 2. And here are some more examples using merge outer or merge right. Now, if you're not familiar with SQL syntax, such as inner, outer, right, or left joins, don't worry about this too much. We don't actually use these in the course. We will always default to something that looks like this in the course. We just use an inner join. However, if you find yourself trying to do these sort of SQL merging and you're already familiar with SQL syntax, just know that Pandas has this how operator or parameter for you to use in case you want that extra functionality. But basically, depending if you're using outer, right, inner, etc., you may find that you have some missing values. Just keep that in mind as you're working with pd.merge. Here's an example of left. And finally, we've arrived at joining. Joining is a convenient method for combining the columns of 2 potentially differently indexed data frames into a single resulting data frame. You can essentially think of this as the same thing as merge, except the keys you want to join on are actually on your index instead of a column. So here I've created 2 data frames, left and right. Notice they have columns A, B, and then C, D, and then the index is actually the keys we're going to join on. Now the syntax you can use is say left.join right, and it will automatically do an inner join between the left and the right, based off of the index keys. If you wanted to merge these two data frames based off of one of their columns, you'd have to use merge. But the join method functionality comes off of one of the data frames. You say .join and then pass in the other data frame. And just like merge, you can specify how, such as inner, left, outer, etc. And remember, this is only for advanced SQL users who are already familiar with that terminology. If you're unfamiliar with that, don't worry about it too much. Let's go ahead and do a quick review of how to join, merge, and concatenate data frames, and we'll go over the key topics you should get out of this lecture. As far as merging, joining, and concatenating data frames, in order to concatenate or glue data frames together, the process is quite simple. You just say pd.concat, and you pass in a list of your data frames. And then you make sure to specify the correct axis, depending if you want to join them together by their rows or by their columns. Next, you have pd.merge, and pd.merge allows you to merge data frames together. And you just pass in your first data frame you want to merge, and then your second data frame you want to merge. And then you say on, and you can pass in just a single column key, or you can pass in a list of keys. And by default, it will merge on inner. If you're unfamiliar with merging SQL tables, don't worry about this how too much. Just worry about one data frame on the left, one data frame on the right, and then on a certain key column or on a list of key columns. That's really the only functionality with pd merge that we'll be using throughout the course. And then for joining is a more advanced method for combining columns of two potentially differently indexed data frames. It's very similar to merge, except you're actually joining on the index instead of a column. And the syntax for that is just the name of the left data frame, .join on the right. We actually won't be using join throughout the course, but I want you to be aware of it, and you can reference this notebook or the documentation in case you ever want to review joining. All right. Great job, thanks, and I'll see you at the next lecture. Hello everyone, and welcome to the operations lecture. In this lecture, we're just going to review some of the most important operations for pandas, as well as learn some useful operations that we haven't gone over yet. Let's go ahead and jump to the Jupyter Notebook to get started. Alright, here I am at the Jupyter Notebook. I went ahead and just copied the first cell of the operations notebook that goes with this lecture in order to create this data frame. It just has 3 columns, call 1, call 2, and call 3, and it has an index of just numbers, 0.
One thing about learning stuff is that sometimes you have to treat it like you're actually in the class. Where it's like, sure, you could go over the same thing over and over and over again until you get it. Sometimes you just got to go through it in order to go back. So that way your progress isn't hindered. Because we're going to get to a point where you're going to get to the project itself, and then that's where most of the learning happens either way. This is just going to be bare brute force memorization. The actual learning and being able to manipulate things comes from the projects. So, doing the repetition of getting all the pandas and NumPy methods down, it's almost not as important as getting through the content and being able to do the project and then get it down. And then you can use it in actual practical ways. Because the project itself is going to make you, like, to make it stick. Because that's some value and some meaning. But yeah.
0, 1, 2, 3. In call 1, we have 4 digits. In call 2, we have 4 numbers here. But notice that 444 is repeated. And then in call 3, we just have 4 sets of strings.
Right.
Let's talk about finding unique values in a data frame. There's 3 main useful methods concerned with finding unique values in a data frame. Imagine we wanted to find all the unique values in column 2. The method we can use for that is just the unique method. And it
I can get through this. How long is my How long is my longest video? Hour 47.
This will return a NumPy array of all the unique values in column 2.
throw in str. Becomes object. Got it. Still object. Oh. Yeah.
Instead of actually wanting the array of unique values, let's say you just actually want the number of values itself. Well, there's two methods for this. You could just check the length of the array that gets returned, and this would respond to 3. There's 3 unique values in column 2. But pandas actually has a built-in method for this, and it's just n unique. And if I run this cell, I get the same answer. All right, so we have unique for actual returning an array of unique values, and n unique if I want the number of unique values. The last useful function I want to show you is value counts. And this basically means if you want a table of the unique values and how many times they show up. You can just use value underscore counts as a method, run this, and this returns how many times each unique value occurred in that column.
That's useful. About the whole thing. Just returns the entire thing back to me. No, here's the count. One of each. Makes sense, I guess.
In this case, 444 occurred twice, and the other numbers occurred 1 time each. Alright, those are 3 very useful methods, and you'll find yourself using them often in the exercises. Let's go ahead and talk about selecting data. We've already gone over conditional selection, but I want to re-emphasize just how important it is and how powerful it is as a tool. We have our data frame, df, and we can use conditional selection by passing in a conditional selection statement, such as saying, return the df where column 1 is greater than 2. And this will return all the rows of the data frame where column 1 happens to be greater than 2. And remember that this command inside is essentially just a Boolean series of false, false, true, true. Now, as a quick reminder, if you want to combine conditions, you can wrap these conditions in parentheses, and then use either an ampersand or a pipe operator, depending if you want and or. And then you can say another condition, such as where call 2, let me pass this in as a string, has equality with 444. And this should return just that last row, 3. And there it is. Okay, that's just a quick reminder of how to select data using conditional selection. Now let's talk about the apply method. The apply method is going to be one of the most powerful tools in your tool belt when using pandas. So let's go ahead and show you how it works. Imagine we have a function, def, times 2, that takes in a value x, and then returns, let's say, x times 2. Alright, a very simple function. Now, you know that you can already grab, for instance, a column and call a built-in function off of it, such as the sum. And that will return the sum of the column. But what if you wanted to apply your own custom function, such as times 2? Well, pandas has the ability to do that. You can just say the column name, and then dot apply, and then you just pass in whatever function you want to apply. In this case, we're going to go ahead and apply times 2. And this will broadcast that function to each element in that column, 2, 4, 6, 8. You can also apply built-in functions, such as length. For instance, if we take a look at column 3, we had a bunch of strings. Let's say we wanted a column that represented the length of each string. Well, then we could just say apply and pass in len. And that returns the length of each string, which in this case was 3 for all of those strings. Apply is going to be especially powerful when you combine it with lambda expressions. That way, you don't need to take the whole time to define an entire function if you're just going to apply it once. For instance, let's go ahead and make a lambda expression out of times 2. I'm going to go ahead and say lambda x colon, and then just x times 2. And I'm going to apply this to column 2. Let's go ahead and see how this works. And there you have it. We were able to multiply each value in that column by 2. And we were able to do this without having to write an entire function for it. We just did this as a lambda expression. And this is the sort of thing you're going to be using all the time as you get more and more comfortable with pandas. This is probably one of the most powerful features of pandas, the ability to apply your own custom lambda expressions or functions. Alright, let's talk about removing columns. Again, if we have df, we want to, let's say, remove column 1. We can just say df drop, pass in the column we want to drop, col1, and then remember, since it's on the columns, we have to specify access is equal to 1. And this will drop that column. If we want this to occur in place, we have to specify in place equals true. Let's go ahead and not run that so we retain our original data frame. If you want to get the column and index names off a data frame, those are actually just attributes of the data frame itself. Meaning you can say df columns, and it'll return this kind of index object, which is essentially just a list of column names. This is going to be especially useful when you're trying to index a column and maybe the spacing is weird or you can't quite figure out what the string is. You can just call df.columns or whatever your data frame name is, and it'll return this list of column names. And you can actually do the same thing for an index. You can say df.index, and it'll give you information of the index. In this case, since it's a range index, it actually just reports back the start, stop, and step size of the index. All right, let's talk about sorting and ordering a data frame. Here we have df, and imagine we wanted to sort it by column 2. Essentially, we want 444 and then 444 again before we see 555 and 66. We can use sort values in order to do this. You call df sort underscore values, and then as an argument, you say by. When we check shift tab here, you can say by, and you can order this off of either the rows or the columns, but essentially you just pass in as an argument the column you want to sort by. So I want to sort this by column 2, and you can say just column 2 as such, shift enter, and now I've sorted this data frame by column 2. Note how the index stays attached to the row, so you don't ever lose that information there. And that's the same thing as saying by column 2. It's the same thing because it expects by to be the first argument.
Right.
All right, let's talk about just a couple more useful operations. A really useful method to find null values in your data frame is the df is null. And this will return a data frame of booleans indicating whether or not the value was null or not. In this case, we get a boolean of all falses because we have no nulls in our data frame. All right, now let's finally talk about one last function or method in pandas called the pivot table. And this methodology will be really familiar for advanced Excel users. I'm going to go ahead and copy and paste some code from the notebook to create a new data frame. Go ahead and check out this data frame. We have something that looks like this. We have A, B, C, and D columns. And notice here that we have repeating values in both the A column, the B column, and the C column. So A column has foos and bars, B has 1, 2s, C has x's and y's, and then D has some integer values. You can use df.pivottable to actually create a pivot table. And if you're not familiar with pivot tables, I wouldn't worry about this too much, but if you are maybe an Excel user who is familiar with pivot tables, hopefully you'll find this functionality useful. Basically, what we're going to do for non-Excel users is just create a multi-index out of this table, or a data frame. The method to do this is pivot underscore table. And pivot underscore table takes in 3 main arguments: the values, the index, and the columns. In this case, let's go ahead and indicate that the values we want in our table are these D values. This is what we actually want the data frame data points to be made up of. So I'm going to say values is equal to the D column, and then I will set my index to be equal to the A column and the B column. And that's basically going to make A and B into a multi-level index. So I'm going to pass in a list then, since it's more than one column, of index A and B. And then finally, I want my actual columns to be defined by the C column. In this case, just C. I'm going to pass that in as a list here. And note that I'm saying C is going to be the column, so I should end up with a column for X and a column for Y. Let's go ahead and see how this works. I'm going to run this one more time here so we can compare the original data frame versus the pivot table that I'm about to create. Alright, so I ran this pivot table command, and let's go ahead and compare the two. Looks like I created an index out of those A and B columns, so that makes sense. Looks like we have bar and foo, and then 1 and 2, repeated. Then, the actual columns I wanted were the C values. In this case, just X and Y, and the actual data point values were the D columns. Note, I do have some null values here, because there were no values that matched up for that specific point. Meaning, if I look back at the original data frame, there is no value that goes with bar to X. So if you look here, you won't find bar to X, you'll only find bar to Y. And similarly, for foo to Y, there is no foo to Y, there's only foo to X. And that's why we have fill in null values here. Okay, feel free to post the Q&A if you have more questions on pivot tables, or want some more resources for examples on pivot tables. We won't really use these that often in the course. In fact, there's only really one extra later on where we're working with heat maps as far as how to use the pivot tables. But for now, only concern yourself with them if you're already familiar with pivot tables from something like Excel. Okay, I hope some of these operations were useful to you. Basically just a grab bag of useful functions and methods that are available to you in pandas. You can go ahead and reference the pandas operation, everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the Data Input and Output lecture. Pandas as a library has the ability to read data and write data to a wide variety of sources. For this lecture, we're going to be concerned with just 4 main data sources: CSV files, Excel files, HTML from the web, and SQL. In order to work with HTML files and SQL,
This is... Oh boy.
write data to a wide variety of CSV files, Excel files, HTML from the web, and SQL. In order to work with HTML files and SQL databases with pandas, you'll need to install 4 libraries. The instructions are in the notebook, or if you just want to do it quickly, these are the 4 libraries you need to install: SQL Alchemy, LXML, HTML5lib, and then the beautiful Soup 4 library. You can do this either with pip or conda. Alright, Once you've installed these libraries and referenced a notebook, you're ready to get started. Let's go ahead and jump to the Jupyter Notebook and show you how to book your ready to get started. Let's go ahead and jump to the Jupyter Notebook and show you how to read and write files with Canvas. Alright, here we are at the Jupyter Notebook. Keep in mind that as we reference the files, such as the example CSV file and the example Excel file, you'll need to make sure they're in the same location as your Jupyter Notebook is. In order to check the location of your Jupyter Notebook, you can just go in a cell and type PWD, do Shift Enter, and it'll report back the
Bro, I thought I installed it on my other drive. Are you serious right now? Okay, I'm gonna stop it here, reinstall Jupyter Notebook, because this is kind of crazy. Or just pause it, I don't know. I'll just run with it for now. I'll fix it tomorrow.
the location. This is the same file location the example CSV file and the example Excel file should be in. If you've downloaded the entire repository of notebooks and are working in the data input and output section or notebook, you should be fine by just referencing the files as if they're already there. Okay, let's go ahead and show how to open and read CSV files. In order to do this, you can just say pd.read_CSV. And then begin typing out the name of your CSV file. In this case, I know it's called example. So as I start typing this out, a nice trick is to click tab, and it will autocomplete the file name. In your case, you may just have example, not example.csv. Let's go ahead and read that in. I did shift enter, and now I can see the CSV file as a data frame, with the columns A, B, C, and D, and 0, 1, 2, 3 as the rows. Note that if I want to read any files, I just use the read underscore command.
Okay, it's not there.
Read that in. I did shift enter, and now I can see the CSV file, name of your CSV file. In this case, I know it's called example. This is the same file location. The example CSV file and the example Excel file should be in.
Let's do some digging real quick.
If you or nope, to do this. So as I start typing this out, in your case, you may just have example, not example.csv. Let's go ahead and read that in. I did shift enter, and now I can see the CSV file as a data frame, with the columns A, B, C, and D, and 0, 1, 2, 3 as the rows. Note that if I want to read any files, I just use the read underscore command, and I can click tab here, and I get this drop-down menu of the variety of formats that pandas can read from. So pandas can read from even your clipboard, CSV, Excel files, HDF files, JSON, pickles, SQL files, tables, etc. Keep in mind that you have a lot of options here. Right now we're just going over the most common ones. Okay. In order to write to a CSV file, you're going to need a data frame. So I'm going to go ahead and just say df is equal to pd.read underscore CSV. And again, I'm just going to do example, tab autocomplete here. And now I have df as that same example df. So I've actually saved it to a variable. Off of a data frame, you can say to underscore. And if you click tab here, you'll notice now you have a variety of formats that you can write to. It's basically almost all the same formats that you can read from. So I'm going to go ahead and say df underscore to CSV. I'm going to label this my underscore output. And the other thing I'm going to do is say index equals false. And the reason for that is because I don't actually want to save this index as a column. Let me go ahead and show you what happens if I don't put index is equal to false and I just put df to CSV. I'm going to go ahead and say pd.read underscore CSV, and I'm going to read the file I just saved, my output. Note I get this column here called unnamed 0, and that was the old index. Now, and the other thing I'm going to do is say index equals false. And the reason for that is that you could read from. So I'm going to go ahead and say df underscore to CSV. I'm going to label this my underscore output. And the other thing I'm going to do is say index equals false. And the reason for that is because I don't actually want to save this index as a column. Let me go ahead and show you what happens if I don't put index is equal to false and I just put df to CSV. I'm going to go ahead and say pd.read underscore CSV, and I'm going to read the file I just saved, my output. Note I get this column here called unnamed 0, and that was the old index. Now if I say df to CSV and set index false and run that cell, and then if I read my output again, then I won't actually save that index and I will automatically assign a range index to the data frame. Keep that in mind as you're saving your CSV files, whether or not it's appropriate for you to say index equals false. Alright, now let's go ahead and move on to reading and writing from Excel files. Pandas can read and write Excel files, but you should keep in mind that Pandas can only import the data. It can't import formulas or images or things like macros. Using that with the read underscore Excel method may cause Pandas to crash. Another thing to note is that you may get an error asking you to install the XLRD library. That should have been automatically installed if you use the Anaconda distribution, but if you did not, you'll go ahead and go to your terminal, and in your terminal or command line, you'll type conda install XLRD, or you'll do the same thing with a pip install. Again, you're not going to do this in a cell, you will actually do this at the command line or terminal. But hopefully if you did the Anaconda distribution, this should have automatically installed along with Pandas. Let's go ahead and see how this works. I'm going to go ahead and show you the Excel file I'll be working with. Here I have a very simple Excel sample. In fact, it looks almost the same as the .csv file we were working with, except here it's denoted that it's in sheet 1. And basically what Pandas thinks a workbook is that a workbook is just a bunch of sheets, and each sheet is a data frame. Meaning I can say pd.read Excel. I pass in the Excel file name, the XLSX file. A good trick for this is to begin typing the file name, press tab, and select it. Again, this only works if the Excel file is in the same location as this notebook. If it's not, you'll need to pass in the whole file path. And then you can say sheet name, and then pass in sheet 1. We'll go ahead and read this, and we get the output we expected. And that's basically it for reading from Excel file. You pass in the file, and then you pass in the sheet name you want, and Pandas tries its best to read it in as a data frame. Writing a data frame to an Excel output is also a very simple process. You just take the data frame you want to write to Excel, say to underscore Excel, pass in the name of the Excel file you want to save it to. Let's go ahead and make a new one called Excel example 2.xlsx, and then we can also specify a sheet name if you want to. Something to note is that when you're saying to underscore Excel, for whatever reason, Pandas, you need to write in sheet underscore name, and then the name of the sheet. We'll go ahead and put in new sheet. Alright, let's go ahead and run this, and that's it. We've saved it to an Excel file. Now let's go ahead and move along to working with HTML. Again, you'll need to install quite a few libraries in order for this to work, and you'll probably need to restart the Jupyter Notebook after that. You can go ahead and check out the notes for this lecture, the notebook for it, to get a list of all the libraries you need to install. I'll go ahead and go to the beginning of this lecture where we show the list of libraries. Let's talk about HTML input. Here, I have a link to the fdic.gov failed bank list page. And here's just a list of all the failed banks by the FDIC, as far as I'm keeping track. It's the Federal Deposit Insurance Corporation, and here we have a bunch of failed banks, the closing date, updated date, etc. But this is basically just an HTML link. This link is in the notebook, so you can go ahead and copy and paste it from there. I'm going to go ahead and copy this link and try to read it in with Pandas. In order to do this, all I have to do is say pd. Well, let's go ahead and make, say, data equals pd dot read HTML, and then as a string, I'm going to pass in that actual HTML link. It'll take a little bit of time to read it, but it should work out if you have all the libraries. Okay, looks like it worked out. Something to note here is that usually this isn't going to directly relate to a data frame. If I check out what data is, if I say type, you'll notice that it's actually a list. And essentially what Pandas tried to do was to find every table element that was in this HTML file. And if you're familiar with HTML, you know that if you can right-click here and view page source, you'll have this list of actual HTML code. And if you're familiar with HTML, you'll know that you can actually look for, just like there's list classes here, there's actually table references. So there's table markings in here in the HTML code. And that's basically what Pandas is going to do, and it's going to make a list of them and convert each item in that list into a data frame. And what you're going to do is just cycle through that list until you find what you wanted to look for. In this case, it should be the very first item in the list. So if we say data at point 0, so the very first item in that list, that's the data frame we were looking for. Bank name, city, updated date, etc. Let's go ahead and just check out the head of that data frame, and that's what this looks like. Again, some things don't copy over exactly. You get a bunch of null values, but keep in mind, Pandas is basically just reading this HTML file as best as it can. Alright, that's HTML, which is essentially just web scraping of Pandas. Let's finally move along to our last topic, which is working with SQL. Now, there's quite a few notes in your notebook regarding SQL and Pandas. Pandas isn't actually probably the best way to read a SQL database, because there are many flavors of SQL engines, such as PostgreSQL, MySQL, SQLite, etc. What we're going to do here is just actually build a very simple SQL engine that's going to be just temporarily held in memory in order to show you how you can use Pandas to read tables completely as data frames. However, I would recommend that you actually do a search for a specific driver dependent on your specific SQL engine. For example, if you go to the notebook for this lecture, you'll see that if you're using PostgreSQL, you should actually use a library called PsychoPG2, which is specifically designed to work with PostgreSQL. Or if you're using MySQL, you should use PyMySQL, another library specifically designed for that specific flavor of SQL. Right now, we're just going to do a very simple example of how Pandas could read in an entire table in SQL if it had to. What you end up doing is saying from SQL alchemy import create engine. And this is going to just allow us to create a very simple SQL engine in memory. I'm going to go ahead and say engine is equal to create underscore engine. And here I'm just going to type in SQLite 3 forward slashes and then memory colon. So I have SQLite colon 3 forward slashes colon memory colon. I'm going to go ahead and run that. And this little thing, this little line of code has created a very temporary, very small SQLite engine database that's running in memory. I'm going to go ahead and take my data frame, that df, and I'm going to say to underscore SQL, and I'm going to write it to that very temporary engine that we have running in memory. So what you're going to do is you're going to say to SQL, you're going to pass in what you want this table to be called. So we'll go ahead and call this my table. And then you pass in the SQL engine you're working with. In this case, it's just an engine. Now, this engine is going to be a connection usually. I would recommend you read through this documentation thoroughly, but again, like I mentioned earlier, Pandas just by itself probably isn't the best source for you to actually read SQL into Pandas directly. You should probably look for specialized Python libraries for whatever version of SQL you're working with. But as far as a very simple setting, you can just say df to SQL, pass in the new table name you want, and then the connection to your SQL engine. And now, I'm going to go ahead and say SQLdf and actually read back that table. So I'm going to say pd read underscore SQL, I pass in the name of my table, in this case it's my table, and then I specify the actual connection I want. So con, and that's just the engine, that very small SQLite database that's happening in memory. And if I go ahead and read that and check out what that looks like, I get SQLdf, and notice that an index is a new column here. Alright, go ahead and feel free to post to the Q&A forums if you're having trouble finding a particular library that works with your SQL engine, or your flavor of SQL. As far as this lecture, the main thing to get out of it is how to read and write to CSV files, because we're only going to be working with CSV files for the rest of the course. As far as your own personal usage, hopefully you can just check out the read underscore methods. There are a lot of them, and you can just look at the documentation or reference a notebook for how to read to a Pandas data frame. Alright, thanks everyone. Go ahead and ask any questions you have on this lecture in the Q&A forum, because there's a lot of options here, and we just don't have time to cover them all. But if you have any questions, I'm happy to answer them in the forums. Thanks everyone, and I'll see you at the next lecture. Hello everyone, sure. In this let's go ahead and jump to the Jupyter Notebook, the Pandas folder we've been working. We'll pronounce it kaggle.com.
Okay. Tomorrow we ball. Let's do these exercises. Man, it's gonna be a fun one. It's gonna be a fun one. It's gonna be a fun one. Do the exercises and then we can finally get into Matplotlib. Ugh. I'm gonna take a little peek into it.
Now that we've finished learning about our data analysis libraries, it's time to actually start visualizing that data. We'll start off by learning about Matplotlib, then we'll move on to Seaborn for statistical plots. Afterwards, we'll learn about Panda's built-in data visualization capabilities, and then we'll see how to use Plotly to create awesome interactive plots with just a few lines of Python code. Thank you so much, and I'll see you at the next lecture. Matplotlib. Matplotlib, or as some people pronounce it, Matplotlib, is the most popular plotting library for Python, and it really gives you complete control over almost every aspect of a figure or plot. And it's designed to have a very similar feel to MATLAB, which is another programming language, and its own graphical plotting capabilities. Matplotlib works very well with pandas and NumPy arrays, which is why we're going to learn about it. Later on, we're going to learn about some other libraries, such as Seaborn, that is actually built off of Matplotlib. But in order to understand those libraries, it's important to understand Matplotlib first. You'll need to install is right here under Gallery. If you click on Gallery, or go to Hello everyone, and then just scroll down to a new cell, figures, or ax. Alright, so there's our plot. You just say .png. I'm going to go ahead and plot axes is equal to customizing the option. Another very useful, most often I'll just either do pluses here, etc. And now we can see lots and lots of many specialized plot types you can do with.
Alright, Leo. Alright. Whew. Stop here. Till next time. Namaste. Cool.